Okay, so this is going to be Unit 24 Introduction. This is the last math packet in your week 3. This sheet should have been on top. It says goes along with Unit 24. Cut this out to help you. So the first thing you need to do is cut this out and cut the inside out as well. And then we are going to proceed with some videos that will help you. Okay, so looking at this, one of these LearnZillion videos that you should have already watched, this is just going to kind of explain what a protractor is.
Here we can see two of those 180-degree protractors that had formed a circle. Like the full protractor, they also have a starting point, a 0. Here we can see that for the protractor on the right. The numbers then increase as we follow it around. What's unique about this particular protractor, though, is that there is also a starting point of 0 on the opposite side. There is a set of numbers that increase from that 0 as well. This way, an angle opening either to the right or to the left can be read using this one particular tool. In this lesson, you have learned what tool is used to measure angles by exploring properties of protractors.
Okay, so your protractor looks a little different. We're going to talk about that in just a second. Here is another video that will kind of help you. Hopefully you've already kind of watched some of these.
When measuring an angle, it is important to estimate first.
Okay, so now we've learned about the 3 types of angles. You have an right angle, an acute angle, and an obtuse angle. So the first thing you want to do before you use the protractor is to estimate. You want to tell me what kind of angle you're working with, because that's going to help you utilize the protractor. If you know that you're working with an acute angle, you know that when you measure it, your degree must be less than 90 degrees.
Using that corner sheet of paper, if it aligns perfectly, we know we are dealing with a right angle or 90 degrees. If the angle opening is less than the corner, it will be an acute angle, less than 90. And if the angle opening like this yellow hexagon is greater than the corner, it's going to give us an obtuse angle larger than 90 degrees. Let's think about that belt loader again. We know that the height can vary depending on the size of the plane, and so this belt can either increase or decrease the angle. But if we picture this angle here with our corner paper, we can tell that angle opening is less than 90. So when we're reading the protractor, we should expect to see a number that is less than 90 degrees. It's always an important thing to do just to make sure you're in the right ballpark. So now we're going to align the protractor so that the center of it is at the vertex of our angle. Extend one edge so that we can see the 0 marking. Have our second ray, and this time we notice that our angle is acute, but it's falling between 2 sets of numbers. It's not exactly at 20 and it's not exactly at 30.
Okay, so if you can see this very closely, you can see the 20 and the 30, and you can also see larger numbers on the bottom. You have 160 and 150. Well, if you told me it was an acute angle, it must be less than 90 degrees. You are not going to read the bottom numbers. It's got to be the numbers that are 20 and 30 on this protractor.
Somewhere in between. So what we need to do is look where we began at 0, move to the 20 mark, and then count how many 1-degree lines there are past the 20-degree spot. And we can see then our ray is pointing to the 23-degree mark. Let's take a look at another example. How about this comfy recliner? If we take a look at the seat as being 1 ray and the back a second,
the first thing you want to do is estimate what kind of angle is this. Hopefully you can see that this is an obtuse angle. So what do I know about obtuse angles? I know that my angle degree is going to be more than 90 degrees. Okay, we're going to stop this video right here. This is also another cool little website that we posted. It's a interactive tool online that helps you use a protractor. Let's see. If you scroll down, there's this activity right here, okay? And you can take a protractor and you can measure the angles. You would move the protractor around like this, and you want to make sure within this circle right here, that's where you want to lay your vertex, right there. And it says that you can rotate it using the arrow keys. So I'm going to use the arrow keys to see if I can line up that 0. Let's see if I can get it right on point. Okay, so it's lined up perfectly on this line right here. You want it to line up with a 0. And you want your vertex to be in the middle. If you're looking at angle looking at angle C, you want to take this line and you want to pull it all the way up until you see you've got 2 numbers right here. Well, first of all, we need to figure out what kind of angle C is. So actually, if we move the protractor out of the way, you can clearly tell me that C is an obtuse angle. So I know it's going to be larger than 90 degrees. Let me put this right back where I had it. So when you pull this line up right here, and you see the numbers 40 and 140, I wonder which angle degree it could be. Well, I know it can't be 40 degrees because you told me it's going to be larger than 90. Therefore, the angle C must be 140 degrees, okay? And then you can type those in right here, all right? This is just a cool activity if you want to play around with it and practice it. Also, if you wanted to line up, I want to point out line up B, you've got to put it in the vertex right there. Let's see if I can move it around. There we go. Okay, and it's lined at 0. And you know that B is an acute angle, so you're going to pull this up. Well, it's between 10 and 20 and 170 and 160. Well, I know it's not 170 and 160, so it's got to be between 10 and 20. It looks like maybe we're at 15, maybe like a 16-degree angle. Okay, I would recommend that you play around with it. You can click try another, it gives you more. Okay, try another. It's really cool. You can rotate it around. All right. All right, so now we're going to look at our introduction. All right, so we are looking at Unit 24, Introduction. This is how to measure angles using a protractor. We did give you a protractor to cut out. I did label this protractor. I will show you. I cut my protractor out. And I actually labeled it the other way as the video had it. If we were at school, we would give you these plastic protractors that have both markings on them. And when you're looking at your Mentoring Minds, this is very similar to the protractor we would actually use if we were in school. It's got both sets of numbers on it. So I want you to be familiar with how to use this. I cut mine out, I cut the center out, and I even poked a little hole right there so I can see that I'm lining up the vertex. So you're not necessarily going to need this particular protractor for Mentoring Minds because everything in Mentoring Minds actually gives you a drawn protractor. However, we did want you to be familiar with how to use one. So we had this, and you can cut it out and you can use it, or you can you know, just keep it for later. All right, so looking at the first part, okay. I'm looking at this protractor and I see several angles. I see an angle here, DCE. I see an angle BCA. I see an angle ACF. I see an angle ECF, an angle DCA, DCF, all kinds of angles there. I need to make sure that I am reading the correct angle. Okay, so it says, what is the measure of angle ACE to the nearest degree? Okay, so first of all, I need to figure out what angle I'm referring to. Angle ACE. Okay, angle ACE. It could also be read angle ECA. Okay, so this one large, and I'm going to try and highlight it. I'm not sure if it's going to show up. Angle ECA. And if you remember, the video said, first of all, you need to tell me what kind of angle that is. That's going to be an obtuse angle. So I know that my degree measurement is going to be larger than 90 degrees. Okay, so that's really important because there's two sets of numbers. Okay, so let's take a peek. I'm going to try and get it zoomed in a little bit more clearly so we can see what we're doing there. All right. Alright, so I know it's obtuse, so it lines up on the vertex, this lines up on the 0, so we can correctly measure. I don't need to move it around any. And looking at this, it looks like it hits at 50 and 130. I wonder which one my answer would be. Well, I know it's not going to be 50 degrees because it's an obtuse angle, so it's got to be 130 degrees. Does that mean that it's obtuse? Yes, it does. So that works. Okay. All right. If you look at number 2, okay, number 2 says, what is the measure of angle BCD to the nearest degree? Okay, so let me move this around. Angle BCD. So this is a bit more tricky because your angle does not start at the 0. So that means we're going to have to do a little subtraction to figure out the difference, okay? So first of all, you need to tell me what kind of angle BCD is. Hopefully you can look at the angle and see that it is an acute angle. It looks like it's almost a right angle, but it's actually acute, so it's going to be less than 90 degrees. And we are going to look at the difference of where it starts. So we have it starting at 10 degrees, and we have it ending at 90 degrees. Well, we've got to subtract to find the degree amount that that angle works with, okay? So what is 90 degrees minus 10 degrees? That is going to be 80 degrees. Now, you have to make sure you understand what I'm saying. This, we did not need to do subtraction with because it started at 0, okay? So if it starts at 0, you don't need to find any difference. But this, there's this piece right here that is not accounted for, so you have to subtract 10. You need to make sure that you pay attention to the numbers because you cannot subtract 170 and 90. Well, I guess you could get 170 and 90 and you would still get 80 degrees. That would be fine. Okay. And then number 3 says, which angle measures 40 degrees? Okay, well, looking at all these, I see angle DCE. I know that measures 10 degrees because we've already calculated that. That's 10 degrees. I know that this angle right here measures 80 degrees because we've already calculated that. Then I see these two angles right here, angle BCA and angle ACF. They both look like they're acute, so we've got to figure out which one measures 40 degrees. Well, I think we're probably going to have to do some subtraction to figure that out. Okay? Let's see if I can line it up for you. Let's first of all measure angle ACF. Okay? So if we look at angle ACF, okay, it starts at 0 degrees, so we are good to go, and it goes all the way up to 50 degrees. So we don't need to do any subtraction, but this angle right here is 50 degrees. So we're looking for something that measures exactly 40 degrees, okay? There is an angle right here, angle ACB. It does not start at 0, so we're going to have to do some subtraction to find the difference in that angle. That's an acute angle, so it's got to be less than 90. let's see, it starts at 50 and it goes to 90. What is 90 minus 50? Oh, that gives us 40. So this must be a 40-degree angle. Okay, therefore, angle AC B measures 40 degrees. Okay, let's move on to number 4. It says Rochelle drew this figure to show the angles formed by 3 sidewalks at a rose garden. I'm going to flip my paper until I feel like it is how I would normally look at it. Okay. Yeah, there we go. I can clearly see that the angle GED is an obtuse angle, okay? And then it looks like these two are acute that make up the in-between angles, okay? All right, I'm going to turn it back and read it. Rochelle drew this figure to show the angles formed by 3 sidewalks at a rose garden. Angle, and we're going to highlight that part, angle DEG, that's that very large obtuse angle. Angle DEG measures 116 degrees total. Okay? Says, what is the measure of angle FEG? FEG. So we're looking for that measurement. Well, you don't necessarily need a protractor for this because it gives you the measurements. We just have to do subtraction problem to find the difference. If you know the total degrees is 116 and this angle that we have used is 66 degrees, you can do a subtraction problem to find the measure of GEF. Okay? The difference is 50, so this part must be 50 degrees. Okay, so it says, what is the measure of angle FEG, 50 degrees? You can check your work by adding these two angle degrees together, and you should get 116. So let's do that. $116, so it checks out. So this must be 50 degrees. All right, so we're going to go ahead and do number 7. I know it's kind of out of order. It says sketch an angle that measures 45 degrees. If you have cut the protractor out, this is where it could come into handy. First of all, I want you to know what kind of angle a 45-degree angle is. That would be an acute angle, so I know it's going to be small and cute. It's less than 90 degrees. Okay, I'm going to draw an angle. Actually, it's usually easier for me to use a straight edge, like a sticky note, to draw the first part of the angle. That's why I like making a line. Okay. So now, that's where I'm going to line up. Zero. Does it line up on there? Yes, it does. Perfect. Now, how would I measure? Let me move this down so you guys can see what I'm doing here. Sorry, I'm going to get it a little bit more situated so you can see exactly what I'm doing. Okay, how would I measure 45 degrees? Okay, well, I'm going to look at the numbers that are printed on the protractor because those are the numbers that are going to help me. Okay, I know it's going to be, here's 90 degrees. So I know it's going to be on this side. It's going to be 45. Well, there's the 40 and the 50, so I'm thinking it's going to be straight in the middle between 40 and 50. Okay. Okay. So I use my protractor to help me. 45 degrees. That angle right there is 45 degrees. Okay. And I usually like to think of it like this. When you have a right angle, the right angle is 90 degrees. Did you know that half of 90 degrees is 45 degrees? So two 45-degree angles make a 90-degree angle. Fun facts. We're going to move on to number 5. I did not even realize that I just basically told you the answer to number 5 as I was doing number 7. So let's read number 5. A lighthouse rotates, okay? The light 45 degrees and then pauses and then rotates another 45 degrees and pauses again. What is the measure of the angle formed by the rays in the beginning and the ending position? So first of all, I want to, I don't like how they didn't give you enough room to actually draw out the angles. Again, I'm going to use a straight edge because Miss Langman can't draw a straight line. Okay, so 45 degrees. Okay, so this is the first rotation. It is 45 degrees. And then it rotates again, okay, another 45 degrees. So if I created another 45 degree angle there, this is the second rotation that I made, and this rotation was another 45 degrees. Well, a way we could get this would be 45 degrees in the first rotation plus 45 degrees in the second rotation would give us a total of 90 degrees. That's how much total that it has rotated. And so like I said when we were doing number 7, a 45 degree angle and another 45 degree angle will give you a total of a 90 degree angle, a right angle right there. Okay? Alright, so if you look at number 6, wow, there's a lot going on here. You've got to pay attention to the angle names that it gives you so you don't get confused. Alright, so I'm going to look and see what we got here. We have an acute angle, an acute angle, an acute angle. This is clearly acute, but I don't know the measurement of it. And all of those are forming a larger angle, okay? So, it says using the given information to find the measure of, I'm sorry, I missed the first part. It says grandmother bought Maria a fan while she was on vacation. The figure shows how the fan looked as Maria opened it. So like one of those paper fans that you open it up, okay? The measure of angle HIM is 92 degrees, okay? So this large angle right here, HIM, the total degrees there is 92 degrees, which means that it is actually an obtuse angle, even though it's very close to a right angle, okay? Well, we know if the total is 92 degrees. Let's look here. It says using the given information to find the measure of angle JIK. So you're looking for that angle amount. That is the one that is the unknown that they do not give you, okay? I do want you to look at the different angle types. The different angle measurements. This one's 23 degrees, this one's 23 degrees, this one's 23 degrees. Could you make a guess and say that one's 23 degrees? It does look like it's a possibility, but we want to make sure that we know the exact amount. There's a couple different ways that you can do this. This is the total. You can subtract 23, subtract 23, subtract 23. You could add 23 3 times and then subtract that. I think that's what I'll do. I'm going to do 23 times 3 because I have 3 sets of 23. 3 times 3, 9, 3 times 2 is 69. Okay, so far I've used 69 degrees total. and I have 92 degrees, so I've got to find that difference. Oh my goodness, it looks like that angle amount is also 23 degrees, okay? 23 degrees, just like the other ones, okay? I don't want you to make that assumption. I did take a guess and think that it probably was 23 degrees. However, I wanted you to do some math to prove your work, okay? And how you could check your work would be adding 23 4 times, or you could do 23 times 4, and you should get 92, okay? All right, so let's open this up. Looking at your words for the Y's, I'm sorry I used permanent marker in some of this. Looking at, let's see, maybe some new vocabulary. You should know what an acute angle is. We've learned decompose in a previous unit. That means to break down into smaller parts. Protractor should be the only new definition for you. But you should be familiar with what a protractor is based on this lesson already, since we have been using a protractor. I'll write it for you, the exact definition. Okay, it is a tool used to measure angles. A tool used to measure angles. So that would be the only new definition that you do not have. A straight angle, you know, is a 180-degree angle. A vertex, just remember the vertex is the point where two rays meet to form the angle. If you have multi or multiple vertex, it's called vertices. Okay, so it's really the same thing. Looking at the vocabulary activity. Okay. It says write 90 degrees or 180 degrees in each blank to make the statement true. I do want to point out to you, as far as 180 degrees, you know that that is called a straight angle. So basically, if you had an angle that looks like this, and you lined it up on the protractor, it's going to line up at 180 degrees. So that's called a straight angle. Okay? All right. Let's look at number 1. It says, an obtuse angle measures more than blank, but less than blank. Okay, so we know that an obtuse is more than 90 degrees, but less than 180 degrees. It cannot be more than 180 degrees because it cannot be bigger than this protractor. Okay? Perpendicular lines form angles that measure, and if you remember perpendicular lines from our previous unit, they look like this. They form angles that measure 90 degrees. Okay. Number 3, the greatest angle measure on a protractor. And remember, I just did that example with you. The greatest angle measure on a protractor is 180 degrees. It's the straight angle. Okay. Number 4, an acute angle measures less than blank. Less than 90 degrees. A straight angle, again, it measures 180 degrees. Number 6, the angle measure that is the same location on both scales of the protractor. So if you look at your protractor, put this page right here. The 90-degree mark is the same on both scales, okay? And when I say scales, it would be looking at the double protractor that Mentoring Minds gives you, and I told you that we would use if we were in school. I went ahead and labeled this one as the double protractor, but the one that has the exact same measurement and the same location is the 90-degree mark, okay? And then finally, it says a right angle measures 90 degrees. All right. All right, so I want you to look at the journal portion. excuse me, it says, imagine that you are giving directions for a new student to travel from your classroom to the library. Explain how to get to the library using direction words and degree measurements. For example, first turn, so you need to know direction words. You've got right. Hopefully you know the difference between your right and your left. You've got left. You've got front. You've got back. Okay. Since this video is for all 4th grade students and not just Miss Langman's class, we need to make sure that I'm not going to go over it with you right now because, like I said, we're from different classes. So from our classroom, okay, when you walk out the door of our classroom, do you take a right or do you take a left to head towards the library? That's the first thing you would write, okay? And how far do you turn? Do you turn all the way around? If you turn all the way around, that would be a 360. So if you only turned halfway, that would be 180, okay? So you need to list the steps, right? And then you're looking at your partner practice. I'm going to see. Okay. All right, so looking at the partner practice here, it's very complex. You need to make sure you pay attention to each angle name. If you look at number 2, something that one of the videos didn't necessarily talk about, if you lined up 2 protractors side by side, let's see if I can. If you had a protractor here, and you had another protractor here, it would actually create a perfect circle. So, if you know that one protractor is 180 degrees, and then you lined it up with another protractor that's 180 degrees, the total amount of degrees in a circle is 360 in the whole circle. Okay? That's something I wanted to clarify with you. Okay? Alright. Let's look at number 3. It's very similar, except you're looking for something that is not true. That means 3 of them are true, and you're looking for the one that's false. You need to make sure you pay attention to the names, and the middle letter is your vertex, okay? And then you're looking at the bunny ears, okay? All right, and when you finish partner practice, you need to upload your answers into the Google form.